Greetings, this is M squared, and we're going to solve some kind of challenging systems of linear equations. And just keep in mind, again, that when you are solving a linear system, which means you're trying to find the solution or the intersection of two lines, you have one of these options. So either the lines will intersect once and you'll have one solution, they're the same line and you have an infinite amount of solutions, they're parallel and you have no solutions. We have equations, we're not doing the graph, so it's important to remember that the slopes will be different for a one solution system, and the slopes will be the same and the y-intercepts will be the same if you have the same line, and the slopes will be the same but the y-intercepts will be different if you have parallel lines. So keep that in mind as we solve these. Now these are a little challenging because of the fractions and decimals, and sometimes that scares people, so we don't want them to scare you, so that's why we're going to practice. Now when you solve by substitution, the goal is to get one of the variables alone. And you know, if this was an option, like if this was a question on a quiz or a test and you had the option of choosing it anyway, I wouldn't choose substitution. But sometimes they make you do substitution, use substitution. So we've got to get one of the variables alone. It doesn't really matter at this point because these look so scary. So we're just going to pick x. We're going to get that x alone. And how we're going to get that x alone is by multiplying by the reciprocal of its coefficient. So we're going to multiply by 7/2. So I'm just going to rewrite that here so that you can kind of see what I'm going to do. You might want to have your calculator handy. I forgot my y there. Okay, so we are going to multiply by 7/2 on each of these fractions. Keep in mind that's negative. Okay, and when I do that here, those cancel out and I'm left with x. When I do it here, just the 2 and the 4 cancel, because 4 divided by 2 is 2. So then I have 7 times 2, which is 14 thirds. 14 and then divided by 3. And over here, that's 8, and 8 times 7 is 56. So to get x alone, I need to move that over. So when I get x alone, I get x equals 14 thirds y plus 56. And now this is what I substitute in for this x. So I have 4/7 x minus 8/3 y equals 16. And I'm going to plug this in right here. So 14 thirds y plus 56. And then I distribute that 4/7. Well, I like to cancel before I actually multiply. 7 goes into 14 twice. So these kind of reduce to 2 right there, and then I'm going to multiply through. So 4 times 2 is 8 thirds, and then when I multiply here, 7 goes into 56 8 times, and 8 times 4 is 32. Hope I'm not going too fast for you there. You could use a calculator. I'll just show you right here. If you have one of these nifty little calculators with a fraction little button, you could say 4 fraction 7 times 14 fraction 3, and it will get you 2 2/3. If you want to change it to an improper fraction, you just go like that, tell it that that's what you want to do, and it gets 8/3. So you can do it on a calculator if you're not familiar with it, doing it just on paper. So what I want you to notice here is that this 8/3 y and this negative 8/3 y cancels out. They go bye-bye because they can make a 0. And what I'm left with is 32 equals 16. Well, remember, whenever I get all my variables to cancel out or the numbers, and on both sides of the equation, whether it's just variables left or just numbers left, if it's true, then it's an infinite amount of solutions. And if it's false, this is false, 32 does not equal 16, then I know I have two parallel lines and that there's no solution. So this one is a no solution because my lines are parallel. Okay, next one. It doesn't matter which one you get alone. I guess I would pick this one because it's just a 1/2 there, 0.5, which means I need to multiply this whole equation by 2 to get rid of that 0.5. So I'm going to take 3.5x minus 0.5y equals 18, and I'm going to multiply it by 2. And when I do that, 2 times 3.5, x is 7x, and this makes 1y. And this makes, what is that? 8 and 8 is 6, 36. And so to get y alone, I'll move it to the other side and move the 36 over. And I'll get y equals 7y minus 36. And that is what I'm going to put in this equation. I'm sorry. That is an x. That is what I'm going to put in this equation for y. So I'm going to rewrite that first equation, but instead of y, I'm going to put my new y. So I'm going to put that 7x minus 36. So I get 2.5x plus, and then if you want to use your nifty little calculator, let's see if I can put it over here where you can actually see it. 1.5 times 7 is 10.5, and 1.5 times 36 is 54. Okay, so now, forgot my x again. I apologize, I continue to forget my x's. 2.5x plus 10.5x. Well, the halves make 11, and then 2 makes 13. So I have 13 x's. And if I add 54 to both sides, I get 13x equals 52. And 13 goes into 52 4 times. So now I know my x is 4. So I have my x coordinate of my system, but I need to find the y coordinate. So I can pick either one of these equations, and I can say I'll pick the first one, 2.5 times 4 plus 1.5y equals negative 2. And this is 10. 2.5 times 4 is 10, plus 1.5y equals negative 2. When I minus 10 from both sides, I get 1.5y equals 12, negative 12. And when I divide by 1.5, 12 divided by 1.5 is 8. So y equals 8. Up here, was that a negative? So it would be a negative 8, because I had a negative 12. And so then I want to check it. So here's my check down here. I'm going to say 3, since I already just put that 4 back into the first one, I don't really need to check that first one. I just need to check into the second equation. So 3.5 times 4 minus 0.5 times negative 8 should equal 18. So 3.5 times 4 is 14. A negative times a negative is a positive, and half of 8 is 4, and 14 plus 4 is indeed 18. So this is my check. I know I'm right, so this is my solution. So we had solved two different ones. This one was a no solution because we had the same slopes, or because when we put everything in, we got things that did not equal. And this one would be inconsistent if you were asked to find out whether they're inconsistent or consistent. And this one would be consistent and independent because we had one solution. So that means the lines intersected at one point. Good luck with that. It's a kind of a challenging one, but you can do it. M squared signing out.